Hello everyone, welcome to In 5 Minutes. In this video we are going to see the new type of concept of reducible to linear differential equation. So this is type 4a. But before that, whenever we are given the equation and this equation is not satisfying the type 1 problem we saw, type 2 and its subtype A, B and C. So it is not satisfying type 1 also, it is not satisfying type 2 also, and it is not satisfying type 3 also. So in that case, we have to reduce the given equation into linear differential equation. In this type is divided into two parts. One is general equation and another is Bernoullis equation. In general equation, it is type 4a and there is also a type 4b. In type 4a, we make our given equation into linear differential equation which will be linear in y, and in 4b we will make our differential equation linear in x. Okay, so in 4a we have two subparts, which is general linear equation and Bernoullis equation. So what is general equation? General equation is of the type f dash of y dy by dx plus, mind my words, it is a linear in y, therefore dy plus f of y p into f of y equal to q. So when we are given this type of equation and it is not of the form type 1, 2 and 3, then it will be a form of 4a when it is dy by dx, or type 4b when it is dx by dy. Okay, so when our equation is in this form, then we do some substitution. What substitution we do? We have to make this equation into type 3, that is we have to reduce this equation to linear differential equation. For that we substitute f of y equal to some other variable u. Okay, if we take the derivative of this term with respect to x, we get f dash of y into dy by dx. We all know whenever there is some function, say y equal to e raised to ax square, what we do, dy by dx is nothing but first we take the derivative of this, then we take the derivative of this part. Similarly, we take the derivative of this, then we take the derivative of inside the bracket, which is the function of y, so dy by dx. So this will be equal to du by dx. So as you can see, if we substitute this term, which is f dash y into dy by dx here as du by dx, so our equation will be du by dx plus p and q here will be the functions of x. Okay, p into f of y we are substituting as u equal to q. So as you can see, this equation is similar to type 3. In type 3 we saw the equation is dy by dx plus p into y equal to q, where p and q are functions of x. So this was linear in y, so this equation is linear in u. So you can draw the analogy between these two. So for this linear in y, the solution is given by y into integrating factor. So in this case the solution will be u into integrating factor equal to integration of q into integrating factor into dx. So this part remains the same, q into integrating factor into dx plus c. In linear equation in y, the integrating factor is e raised to integration of p dx, so this will also remain the same. So as you can see, this equation was not linear, but we have made it linear by substituting this function equal to u, then it become linear in u. Its solution can be found out by using this and this equations. Okay, so this is the general type. There is one more type, which is Bernoullis equation. So what is Bernoullis equation? Bernoullis equation is nothing but dy by dx plus p into y equal to q into y raised to n. So this equation, whenever our equation is in this form, then it is called as Bernoullis equations. Okay, whenever we have a Bernoullis equation, so in 4a, in type 4a, this is the second subtype. Okay, whenever we have a Bernoullis equation in which there is y raised to n, then we divide this y raised to n. So we get 1 upon y raised to n dy by dx plus p upon this y and y raised to n, so it will become y raised to n minus 1 equal to q. So as you can see in this part is nothing but it is also of the form f dash of y into dy by dx plus p f of y equal to q, where f of y is 1 upon y raised to n minus 1. If we take the derivative of this, we will get minus 1 n minus 1 upon y raised to n minus 1 plus 1, so which is y raised to n. So as you can see, this Bernoullis equation which has y raised to n, we will divide by y raised to n throughout, then this will become of the type general differential equation, and we follow the same procedure as we used to follow for this type of problem. So this concept is really very complex. When we see the problem on this concept will be more clear. So problem on this we will see in our next video. So stay tuned for our future lectures.